Hello. In this video, we are going to look at the determination of hydronium ion concentration using an ion selective electrode, the pH electrode. Our goal in this experiment is to become familiar with basic methods of ion selective electrodes for quantitative analysis. Ion selective electrodes are also known as ISEs. Our two specific objectives in this experiment. First is to generate a calibration curve for the hydronium ion. And the second was to determine the identity of a weak unknown acid. Ion selective electrodes, or ISEs, are designed to respond to specific ions. They might respond to lithium, sodium, magnesium, barium, ammonium or copper ions, or nitrate, cyanide, or the halogens, chloride, iodide, bromide, and fluoride. And there are others also. These are just a few of them. And they're used in many applications. They're used in environmental chemistry to do an analysis. They're also often used in the food industry, for example. They give rapid results as they have short response times. They're relatively inexpensive. They're very portable, so it makes it easy for environmental chemists, for example, to take them out into the field. But you need to be aware of the chemistry, because ions can interfere with one another. So you need to know what's in your sample ahead of time and make sure that there's not an interference that's taking place. From a practical standpoint, you need to know some things about the use and care of ion selective electrodes. First off, they're fragile, so be gentle with them. They're not greatly expensive, but they do cost something, so be careful with them. And one of the first things to note is that you'll want to remove excess solution as you go from one solution to another, one sample to another. So you'll gently pat them dry. Don't wipe them. There are two reasons for this. One is that the electrodes are fragile. You don't want to break them. So that's why you gently pat them. The second is you don't want to wipe them because that can cause static electricity, which will lead to reading errors. Never let an electrode go dry. You always store it in some sort of solution. But that solution is never distilled water. It's a solution that's specific to the ion selective electrode that you're using. So let's talk in particular about the pH electrode. That's the ion selective electrode that we will be using in this experiment. It uses something that's known as a glass electrode that has a porous surface that allows us to compare the hydrogen ion concentration on the inside versus that on the outside, and that difference leads to a potential reading that we can then record. It's actually a combination electrode that incorporates both the glass electrode that does the pH measuring and the reference electrode that's needed to complete the measurement. They're all in one body. So after calibrating your electrode, you'll be doing your experiment. And you'll want to submerge your pH electrode in a solution with stirring and record the millivolt reading. So you may have to switch your meter from pH to the millivolt reading by pressing the mode button. And so you'll be measuring a set of standards from pH 2 to pH 10, so from acid to base. We want to skip pH 6. You'll also be measuring three solutions, three weak acids of acetic acid, formic acid, and potassium hydrogen phthalate. And you'll be determining an unknown. And that unknown is going to be one of those three weak acids. So you want to measure each solution once, then repeat it 2 more times. Following carefully the procedure that's outlined in your lab manual about how to rinse the electrodes and pat them dry in between changing each solution. So your lab notebook, you may want to set up a chart that looks like this, where you're recording the molarity of the hydrogen ion concentration, which you would get from the buffer that you're using, and then the 3 readings, potential millivolt readings that you have for each solution that you're analyzing. Plus you'll have your 3 weak acids plus your unknown. So what you're going to wind up doing is generating a spreadsheet in Excel. And so you'll want to enter the values that you have from your lab notebook. And so your standards, which are the pH buffers, you'll enter for the hydrogen ion concentration. And then when you wind up doing your plot, the x-axis, the x-coordinates will be pH, and that'll be along your x-axis. That will form your x-axis. And then your y-coordinate will be your millivolt. And so you'll set it up so that your y-axis is the potential millivolts. You'll want to use the average of your 3 trials, and you'll want to go ahead and determine what the standard deviation of those 3 trials are. Then you'll want to look at the handout about using the line est function in Excel, or line estimate. What that will do for you is it will determine the slope in the pH, and the slope and intercept of your plot. And so, for example, for the MS slope, your slope here is minus 56.97, and your intercept is 424.54. So you'll generate a plot that looks something like this, and you generate an equation y is equal to mx plus b, where your slope and intercept came from that line s function that we saw on the previous slide. You'll want to compare this slope to the theoretical slope in the Nernst equation. You'll also want to determine an r-squared value, which shows you how the linearity of the plot is. You'll use this equation to solve for the pH of your known and your unknown acid solutions. And you're going to use the standard deviation to make error bars. These error bars should be vertical only, and they may wind up being too small to see. To learn more about how to do this, look at page 97 of your textbook. So, safety precautions, normal safety precautions. Follow your laboratory practice. Use your PPE appropriately. We are using some weak acids, so they are corrosive, and some of them may have some health effects. All those solutions may go down the drain with running water. Make sure that you thoroughly rinse all the volumetric glassware that you might have used when you complete the lab. So enjoy using the pH meters and have fun in lab. Thanks for watching.